Hey y'all. Today's lesson is equations and two variable. Make sure you have your outline if I gave you one. So far we've had equations with one variable, an x, a y, an m, a w, but now you're going to have equations with two variables. Normally, the equation will look maybe something like this, y equals mx plus b. We'll talk about this later, but m and b, if the equation looks like this, m and b are numbers. Those are going to be like just numbers. And the x and the y are your variables. So an example could be y equals 3x plus 2. That's just an example of an equation with two variables. Now, we're not going to be solving these equations necessarily because they have two variables, but we're going to be using them, finding solutions, and graphing them. So the solution is an ordered pair, x, y. That's why we have an x, y. So we're going to be finding the solutions, x, y, that make the equation true. So an example, here's an equation with two variables, x plus y equals 5. I know it's not in that form, it's just another way. X plus y equals 5. One solution is the ordered pair 2, 3, because if you put in 2 plus 3, that makes the equation true. Another solution would be 1, 4, because if you put in 1 plus 4, it equals 5. You can have another solution with a negative, like x could be negative 2 and y would be 7. So the ordered pair negative 2, 7 is also a solution. The difference with these equations in two variable is you're going to have many solutions. When we had another equation, maybe, and you solved it, you got x is 4. That meant the solution was 4. X had to be 4. But when you have equations in two variable, a lot of times you're going to have many ordered pairs that can actually be your solution. So we're going to talk about that, equations in two variable. All right, example 1. Is the ordered pair a solution? Is the ordered pair a solution to the equation? So in this first example, A, 7, negative 6. This is your x and this is your y. Does this solution work for this equation? Well, the best thing to do is to test it out. You're going to substitute 7 in for your x and negative 6 in for your y. I've just plugged them in. Do that on your paper. And 3 times negative 6 is negative 18. 7 plus negative 18 is negative 11. And the does not equal 14, so the answer is no. This is not a solution because it does not make the equation true. Let's try B together. Is 4, 7, I'll have hair. Is 4, 7 a solution for this equation? So this is your x and y. Let's plug it in. 2 times 4 plus 3 times 7, and does that equal 29? 8 plus 21, and 29 equals 29, so the answer is yes. That is a solution because it makes my equation true. It might not be the only solution, but it is a solution to the equation. All right, example 2. Sorry. Write in function form. So, function form is always going to start with y equals. That's what our goal is, y equals. To get y by itself, we want to isolate y. Here are just a few steps. The first thing you want to do is you want to move x over. Whatever the term is for x, you want to move it over. And then if y has a coefficient, you want to divide by the coefficient. Now, to move x over, cross the equal sign, you're going to either add or subtract. To move x over, you're going to either add or subtract. So I'm going to show you some examples of writing a function in function form, writing an equation in function form. So let's start with A. 4x plus y equals 14. We want y by itself, so I need to get rid of this 4x. I'm going to subtract 4x from both sides. Those are going to cancel, and now I have y. So here's just, it might not make sense to you now, but you want to put your x value first. It's going to set things up so much easier for you in the future. This is a negative 4x, and then that is a positive 15. You cannot combine them because they are not like terms. You cannot put them together and get 11 because they're not like terms. And this would be your final answer. That is function form. Y equals negative 4x plus 15. That's what we're aiming for. B, x plus 3y equals 15. Oh, they both have 15. No, not really. We are going to subtract x on both sides. 3y equals negative x plus 15. It's negative because we subtracted, and this is a positive 15. But I have a number in front of y, so I want to divide by that coefficient. I'm going to divide by 3, which means I need to divide every term by 3. I don't just do one big division and divide by 3. I want to divide every term by 3. Now this, do you remember what number we have in front of the x? We can put a 1. This is negative 1/3 x, and now hopefully you see where I got my 1/3 from. Negative 1 divided by 3, so negative 1/3 plus 15 divided by 3 is 5. Ooh. And then that would be my equation and function form. So I'm going to go to the other side. 5x minus y equals 9. I'm going to subtract 5x on both sides. Maybe you have noticed a pattern. We always move x first. This time I have negative y, negative 5x plus 9. Because my 9 is positive, so it's going to be plus 9. You cannot have a negative y, and remember there's like a 1 there, so we're going to divide by negative 1. And when you divide by negative, it's going to switch all the symbols. When you divide by negative, it's going to switch them from negative to positive and positive to negative. Negative 5 divided by negative 1 is a positive 5. And then a positive 9 divided by a negative 1 is going to be a negative 9. And we're just going to put minus 9. Okay? That may have been fast. If you need to, re-listen to the explanations, but it's the same process. You're going to move the x over and divide by the coefficients. All right, example 3. Write in function form, then list 4 solutions. So we're going to write these equations in function notation and function form, then we're going to find some solutions. So the way we do this, just like we did before, we're going to subtract. I'm going to come to this side. We're going to subtract 4x, and I'm left with negative 12y equals negative 4x minus 36. This is a minus because of my negative right there. I need to divide by negative 12. My negative 12s cancel out. Y equals negative 4 divided by negative 12. So the negatives will cancel, and this is going to give me 1/3 again. I'm simplifying. 1/3 x. Negative 36 divided by negative 12 is a positive 3. So there is my function form. And I want to find 4 solutions. The way you find a solution is you pick values for x. We need to pick some values for x. Now notice my x, that's my input, remember? That's the number I'm inputting into my function. That number is going to be multiplied by 1/3. So it's best to use multiples of 3. So I would suggest negative 3, 0, 3, and 6. Negative 3, 0, 6. If you used 1 and 2, you're just going to come out with a fraction, and let's not do that. Let's just use integers. Negative 3 times 1/3 is negative 1, plus 3 would be positive 2. 0 plus 3 is 3. 1/3 times 3 is 1, plus 3 is 4. And then 1/3 of 6 is 2, 2 plus 3 is 5. So here I've made a table. I've put my solution, I've put my inputs in and I've got my outputs. And now my solutions are negative 3, 2, 0, 3, 3, 4, and 6, 5. Those would be 4 solutions to my function. I changed my function to function form, and then I found 4 solutions. Let's do this one together. 4y equals 8x plus 12. My x is already moved over, so I just have to divide by 4. This one's nice and simple. Y equals 2x plus 3. My 2 comes from 8 divided by 4, and 12 divided by 4 is 3. So here's my function. And now, because I'm multiplying x by 2, I can use whatever values I want. So I'm going to use -1, 0, 1, and 2. I don't have a fraction to try to worry about and keep my numbers nice and neat. So I plug them in. 2 times -1 is -2 plus 3 is 1. 0 plus 3 is 3. 2 times 1 is 2, plus 3 is 5. 2 times 2, so I'm plugging in. 2 times 2 is 4. 4 plus 3 is 7. My solutions are ordered pairs, -1, 1, 0, 3, 1, 5, 2, 7. Okay? So, on this one, I want you to try. Pause it, you try it, and then press play when you're ready to see the answer. All right, here is the function form. Subtract 5y, divide by -1. And then whichever numbers you used, I would use -1, 0, 1, and 2. Your 4 solutions are -1, -11, 0, -6, 1, -1, and 2, 4. If you used different numbers for your input, if you used -2, -1, 0, 1, then your numbers might be different. But we're going to practice more of this in class.